Hey there, Math 112 fans. Going to finish this up with the discussion of the area between curves. As you know, there will be a question, at least in winter 2025, where we do such a problem. We've made the connection between an integral and area, and now we are going to use it to find the area between two curves. So I think we have enough time here just to do a quick recap. These are questions from here on the left are questions from your homework. If you have a function y equals 16 and you want to compute the area from 0 to 4, we have integral notation for it. Now, in that case, we don't really need calculus, but just to recap, that represents that area. And it makes sense because if you did the antiderivative, it's going to be this, and it's going to end up just being 4 times 16, as you would expect. If you then take the other curve, which is this parabola, y equals x squared, and you go all the way over to 4, it turns out, now this is not as easy to sort of verify and believe, you have to believe me on this one, but that the integral also gives that area. And you can do the antiderivative, plug in a 4, plug in a 0, and you have it. I think it's fairly easy to convince yourself that if you subtract this second number from the first number, you're going to get the area between them. And that's all this question is saying. Okay, so if you need to find this area, you actually can do it in 2 steps if you want. You can compute the big area and subtract the smaller area. That's correct. But we really would like you to practice putting them together because it's just better. It's faster. It's typically easier to compute. Okay, so we did that in class. We talked about it. You think about this as the starting x value. And I talked in class, I walked along. I was like, all right, let's walk and draw a little line and tell me when I hit the region. We hit the buzzer. That's the starting x value. You can see that it's x equals 0. And then we're like mowing the lawn. We're in the region. We're between here and here. We're between here and there. We're between here and here, and so on. And that's going to keep going until we get there. And then we leave the region. That was at 4 when we left the region. So this is the start. This is the end. Now, how do we categorize how we think about the other 2 values? Well, if you were standing at any of the x values between 0 and 4, and you have your lawnmower, and you start walking towards the region, you don't turn your lawnmower on until you get to x squared. So like if x is 2, you'd wait till you got to 4. If x is 3, you'd wait till you got to 9. That's the bottom of your lawn, so to speak. And then you're going to have the mower on, and you're going to walk all the way up. Our goal is to touch every blade of grass in the region, so to speak. This is the top. Now, if you take Math 125, we talk about this in a lot more detail and other ways we can do it and how we can do it left and right. In Math 112, we're only doing the integral of top minus bottom. But through all these explanations I just gave you, I'm trying to convince you that indeed is the area. All right. For those of you in my class this winter 2025, you know that I'm going to ask you a question to directly do that. All right, so you're going to have to set it up. You're going to have to realize the top and bottom and intersections. And then I'm asking you to actually compute it and plug in a 0 and 4. So that becomes an opportunity to use those antiderivative skills we've been talking about. And you're going to plug in a 4 here. You're going to plug in a 0 here. And then it's maybe calculator time. Here, let me turn on my calculator. Ooh, fancy. So then I'm going to do 4 times 16. Yay. 464. I'm going to write that here. 64 minus, okay, I'd like to have 4 cubed. I strongly encourage my students to calculate in pieces. So that's 64 over 3. If you're doing a homework question where it says given exact, and these are zeros, minus 0, that's all going to be 0. So if you're doing a homework question that says given exact value, I think you probably can type it in like that, but I would just get a common denominator. Meaning I'd multiply top and bottom by 3. So just a quick review, 60. On the test, I don't care about this. You can leave it as a decimal. So I got 192. So this is 192 over 3 minus 64 over 3. So I need to do 192 minus 64. Yay, 128 over 3. Is 128 divisible by 3? Well, that's another question I would love to talk about, but I'm sure if I do, it'll be a big distraction. But if you add the digits, you get 11, and 11's not divisible by 3. If you don't know that, I'm always sad that not more people know that if you add the digits and it's divisible by 3, then the original number is divisible by 3. But I have a separate video on that, and that has nothing to do with this course. But if you're interested, watch my video on how to check for divisibility. Okay, that's one thing. Then you have more. So a problem like this, you had, and when you're doing this in the homework, you had to find those intersections, which were -1 and 2. That was the start. That was the end. And then you were doing top minus bottom. And then the rest is integration. You integrate. And you have calculator work to do. So there will be some calculation. This is why it's really important you bring a calculator to the test. One half this squared. And you plug in these numbers, 2, 2, 2. And it's good to practice when you're doing the homework, these calculations, so that, I mean, this is your exam. Well, I would say this is bigger than your exam, but this is about, that's not that bad. If you think about doing these pieces, this is actually 4 divided by 2, so it's 2. So if you can do just a tiny bit in your head, it's not as bad. Don't fight that. So this is going to be 1/2. This is going to be -2 minus cube. So it's going to be plus 1/3. And then you're just going to keep going. Distribute the negative. Collect some numbers. We don't want to be scared of arithmetic here. We can do this. And the place you're practicing is the homework. And if we just go a little further, I'm going to start to collect my whole numbers. So that 2 and 6 is 8. -8/3 and another -8/3 is actually -9/3. Ooh, that's nice. -1/2. I've unfortunately ran into my head as I do sometimes. Let's make my camera, goes away. So we have 8 - 3 -1/2. But at any point here, you could plug in your calculator. I'm perfectly fine with 4.5. There we go. And let me know if I made a mistake in the comments. If I was doing this myself on an exam, I would take more time. My goal here is to talk about setup, but I don't want anybody to be surprised by this. I'm not going to do this homework question, then I'm doing all your homework. So you get to try that. I looked, I found an old final question. And you won't see this on my old midterms because we didn't cover it at that point. So this is why part of why I'm making this. I'm telling you explicitly that this will be on your second exam. It doesn't matter that it's not in the previous exams, because I've told you explicitly in class this will be there. So you got to be ready. Okay, so we do need this intersection so that we know where it ends. It told us it started at 1. When are they equal? I think it's 4. Square root of 4 is 2, and I put, 4. So we need to do the integral from 1 to 4 of top minus bottom. And I'm going to call that 1/2 x. And then you're doing integration. And what do you get? You get x to the 3/2. You get 2/3 minus 1/4 x squared from 1 to 4. And then you compute. You're going to plug in a 4 everywhere. 2/3. 4 to the 3/2 minus 1/4. 4 squared. And then 2/3. This was an old final. The numbers are actually really nice because 4 to the 3/2 is actually the square root of 4 cubed. So it's actually 8. We can even do that in our head because the square root of 4 is 2. 2 cubed is 8. And this is actually pretty nice too because it's just 4. Okay, I think I'm going to stop, and you could do it as a decimal. That's fine. We have another one here. How do we do this one? You would need to know where it starts. You would need to know where it ends. And you would do top minus bottom. So in this case, the only thing we don't know is the starting and ending. We know the rest. So the challenge here is that you would need to do the intersection. It's not terrible, but it's the key step. Get everything to one side. I think this one nicely factors. I suspect it does because I'm the instructor and I know I would have made it do it. But two numbers multiply together to give -6 and add together to give -1. How about -3 and 2? Okay, so then you have two possibilities. X minus 3 is 0, or x plus 2 is 0. So we have 3 or -2. So this must be -2. This must be 3. And then we're going to compute. All right. So that kind of finishes up the skills and pieces that can be on exam 2. As my students know, this is going to be, at least in winter 2025, this will be the last question on that exam. Now go prepare.